Okay, this is similar triangles, form K. It's the last page of the packet we have. We have three ways to show that triangles are similar, three ways to prove that they're similar: angle, angle, side, angle, side, and side, side, side. So you need to find either, right? So to show that two figures are similar, you need to show that all the sides are proportional and all the corresponding angles are congruent. But for triangles, we have three shortcuts. Angle, angle is the first one. You need to show, to use angle, angle, you just have to show two pair of angles are congruent. Then you know the triangles are similar. Side, angle, side, you just need to show one pair of angles congruent, and then two pair of sides are proportional, and that angle needs to be between the two pair of sides. And then for side, 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 you just need to show that three sides are proportional. Okay. So it's easiest to start with angles. So here we know that angle Q, well, for this one it's probably easiest to draw out the two triangles separately. So let's do that. So 2 and 3. So we have QUR. And then the big one here is QTS. Okay, QS is going to be, QR is 2 and RS is 6, so QS is going to be 8 units long. QT, so QU is 3, U2 is 7, so the whole thing is 10. Okay. So let's start with angles. They both share angle Q. So we have one pair of angles congruent. Angle Q is congruent to angle Q. That's a pair of angles that are congruent. Okay, but we don't know anything about any of the other angles. So we have to look at the sides now. And we need to check and see if we have two pair of sides that are proportional. So 3 would correspond with 10, and 2 corresponds with 8. But those ratios are not equal, therefore those sides are not going to be proportional. They're not expanding. This one's not getting larger at the same rate. This one gets 4 times larger, but this one only gets 10/3 larger. Okay, so this one we would say no, sides are not proportional. Right, our ratios didn't equal each other, so our sides were not proportional. Okay, for number 2, they don't give us any information on any of the angles. So we're not going to use angle, angle, or side, angle, side. And remember, if these are going to be proportional, the smallest side of one figure is going to match up with the smallest side of the other, and the largest from one figure is going to match up with the largest from the other. So the smallest in the first one is 12, so 12 is going to correspond with 8. 30 is in the middle, so it's going to correspond with 20 because 20 is in the middle. And then the largest two sides will correspond with each other, so that's 36 and 24. Now we need to check and see if these ratios are equal, and if you put them in the calculator, you're going to get 3/2, or 1.5 for all of them. So since we have 3 ratios that are equal, 3 ratios of the corresponding sides, that tells us that those 3 pair of sides are proportional. And if we know that the 3 pair of sides are proportional in a triangle, we know that triangles are similar. So this one is yes. By side, side, side. We need to also do a similarity statement for triangle ABC is similar to triangle. So A matches up with O. It's between the 30 and the 36, so between the 20 and the 24 is O. B is between the smallest and the largest, so that's P. And then C matches with number 3. So again, this one's very similar to number 1. You have a angle H is congruent to angle H. And that's the only thing we know about the angles, and then we have to check the sides. So in this triangle, our sides are 50, okay, and then 40. So they're going to match up with, 50 is going to match up with the whole side of the big triangle, so 75, and the whole side here, which is 60. If we want to draw them out separately again, we can do that. So this is 75 and this is 60. Okay, that's the big one. Okay, and then the small one here is going to be 50 and 40, and then they both have this angle in common. So if you redraw them, the side lengths of the small triangle here are 50 and 40, and the length sides of the big triangle, the red one, are 75 and 60. So 50 is to 75, is 40 is to 60. And you put that in the calculator, you can get 2/3 for both of them. So we have two ratios that are equal, one pair of angles. So we're going to say yes by side angle side. We have two ratios that are equal. That's your S and your S. And then the angle between them, angle H, is congruent to angle H by the reflexive property. It's equal to itself. Both triangles have that same angle. Okay, and a similarity statement. So triangle HGI would be similar to triangle. H corresponds with H, G corresponds with F, and then I corresponds with E. So HF. Again, you can name the first one 6 different ways. You just have to match up the vertices for the second. Okay, here they're giving us angles. So probably the only thing we can look for is angle, because they don't give us any information about the sides at all. So we're looking for angle. We need two pair of angles to be congruent. They give us one pair, Y and K. And then they give us 48 and 63. So we need to check and see what J and X are to see if we have one pair that matches up. So to do that, 180 minus 48 minus 76. Right, that's going to give us 56. Then over here, 180 minus 76 minus 63 is going to give us 41. So we have angle K is congruent to angle Y. But then we don't have anything else, so we're going to say no. Angles not all congruent. Not all the angles are congruent. Okay, so that one's going to be no. They do not have two pair of angles. Okay, number 5. They help us out a little bit. First step in any proof is you're given. It helps to redraw these triangles, so I'm going to redraw two separate triangles. So I'm going to draw the blue one here. P, T, Q. And I'm going to draw the big one in red. So the big one is P, S, R. Okay, PQ is 3/4 the size of PR, and PT is 3/4 the size of PS. So in the second step they give us, we need to figure out how they went from the first step to the second step. And all they simply did here is they divided by PR on both sides. So they divided by PR. Here they divided by PS. Right, so all they did here was the division property of equality. Property of equality, right? They divided both sides by PS. Okay. Now they have that PQ over PR equals 3/4 and PT over PS equals 3/4. So then they used the transitive property, right? If they're both equal to 3/4, then they're equal to each other. Right, that's your transitive. And then what do we know angle P is congruent to in the other triangle? Angle P matches up with angle P. And why are they congruent? That is our reflexive property. Right? It's equal to itself. So angle P is congruent to angle P. So how many pair of angles are congruent here? We have one pair of angles. And here we have two pair of sides. So which theorem are we going to use? We're going to use side, angle, side. Right? We know that PQ over PR equals PT over PS. So that's two pair of sides that are proportional, because those two ratios are equal. And we have the angle between those two sides congruent. So side, angle, side, that's going to tell us that triangle PQT is similar to triangle PRS. So you just simply take what they give you, they divide both sides by PR, and this side they divide both sides by PS. That's the division property of equality, because you're dividing on both sides. Then they simply, since both of these ratios equal 3/4, they set them equal to each other. That's the transitive property. You could have also used substitution. Right? And that tells you two sides are proportional, because you have two ratios of the corresponding sides that are equal. PQ to PR equals PT to PS. So that's two sides proportional. We know angle P is congruent to angle P by the reflexive property, because it's part of both triangles. And then that's one pair of angles, so you have side, angle, side. It tells you your triangles are similar. And the scale factor would be 3/4, or 4/3. 6 and 7. Explain why the triangles are similar, then find the distance between them. So they give you one pair of angles, but you can fill in vertical angles. So that's angle-angle similarity. Right? Tells us the triangles are similar. If the triangles are similar, we know the sides are proportional, so we can set up a proportion. So 30 is going to correspond with x, and then 50 is going to match up with 80. We can then cross multiply. So that's 50x equals 2,400 divided by 50. X equals 4.8, 48. Right? 5 goes in 24, 4.8 times. Yes? No? Yeah. Okay. Over here, again, you have two pair of angles that are congruent, so angle-angle similarity tells us the triangles are similar. If the triangles are similar, the sides are proportional. So 6 is the height. I don't know why they made it so complicated looking. It's the school building though, but the height of the school building is 6. So 6 matches with x, and 4.5 with 12. We cross multiply, 4.5x equals 72. Divide by 4.5. X is going to be 15 something. 15 point something. Oh, it's 4.5. I don't know why I wrote 4. 16 feet. Oh. Yeah, okay. Alright, and we can check our answer. So 6 divided by 16 should equal 4.5 divided by 12. And they do. So we're good. 16 feet. The flagpole is 16 feet. Yep. Okay, a 1.6 meter tall woman stands next to the Eiffel Tower. Okay, so 1.6 feet tall. Her shadow at this time of the day is 0.5 feet long, or meters. Okay, the tower has a shadow of 93.75, and we want to know the height. Let's call it x. The height. How tall is it? Okay, so the person, the woman, and the tower are both standing at right angles, and then the angle of the sun is going to be the same. Right, it's the same time of day, and she's standing next to it, so it's going to be close enough where we can consider that angle equal. So you have two pair of angles that are congruent, so you have angle-angle similarity, which means the sides of these triangles here are proportional. So the height of the woman relates to the height of the Eiffel Tower, just as the shadow of the woman relates to the shadow of the Eiffel Tower. Okay, you could have also done 1.6 divided by 0.5 equals x over 93.75. That would work as well. And then the other way is 0.5 over 1.6 equals 93.75 over x, or x over 1.6 equals 93.75 over 0.5. All four of those proportions will get you the same answer. When you cross multiply, you will get 0.5x equals whatever 1.6 times 93.75 is. It's 150. So you get 0.5x 150, and x is going to be 300 meters. So 300 meters. So 300 divided by 93.75 should be the same as 1.6 divided by 0.5, 3.2. At 4 p.m., Carl stands next to his house and measures his shadow and the house's shadow. Carl's shadow is 8 feet long. The house's shadow is 48 feet long. If Carl is 6 feet tall, how tall is his house? So here's Carl. Sun's over here, coming down, the shadow is 8 feet. He's 6 feet tall, the shadow is 8 feet. Here's the house, we don't know how tall it is, but the shadow is at 48 feet. So, assuming Carl stands at a right angle and the house stands at a right angle, the angle of the sun is the same, so we have angle-angle similarity, which tells us our triangles are similar, which means sides are proportional, so you can set it up. 6 over 8 equals x over 48, or 6 over x equals 8 over 48. Either one of those is fine. Cross multiply, you get 8x. 48 times 6, that's going to be 288. Put in the calculator just to make sure. 288 divided by 8. So 8 goes into here 3 times. So 46, 36. I guess it's 36. That's what the calculator is telling me. Oh, 36, yeah. That's what I said, 36. Feet, 36 feet. Right, if you want to check that, 36 divided by 48 should equal 6 divided by 8. They both equal 3/4, so we know we're good. Alright, number 10. Jacob wants to use his indirect measurements to find the height of his school. He knows the basketball pole next to the school is 13 feet high. He measures the length of the pole's shadow. At the same time of day, he measures the length of the school's shadow. He then writes the proportion. What error has Jacob made? So let's see. He wants to use indirect measurement to find the height of the school. He knows that the basketball pole next to the school is 13 feet high. Okay. And he wants to measure its shadow. Shadow of the pole. Or we call it the pole shadow. Okay. And then he wants to do the same thing with the school. So that he has the school. And then he has the school shadow. I could spell the word school, right? Okay. So he did 13 feet is to the school height, right? These would be angle similarity because you'd have right angles. Okay, so 13 is the school height as the school's shadow. So the problem is he flipped these, right? So 13 is the school height as the pole shadow is to the school shadow. So he can't set up that proportion. He can do 13 over the school height equals the pole shadow over the school shadow. He could do 13 over the pole shadow equals the school height over the school shadow. But he can't relate 13 to the school shadow, right? Ratios relate numbers together. The height of the pole and the height of the school are related because they're both heights. And the 13 and the pole shadow are related because of the pole. But the 13, the height of the pole is not related to the shadow of the school. Okay, explain why there is an angle similarity postulate, but not an angle congruence postulate. Okay. So if you know that you have two angles that are congruent, right? Angle similarity tells us two angles are congruent. So if we have two triangles here, A, B, C, and D, E, F. Right, if we know A is congruent to D and B is congruent to E, then we can use the third angle theorem, right? If you know two angles of a triangle are congruent, you're going to know the third angle is congruent. Okay. Right, and since you have three pair of angles congruent, you're going to know that your triangles are similar, right? They're the same shape. Because all three angles are congruent, they have the same shape. So same angles congruent. And that equals the same shape. Right? So these two triangles are the same shape. That means they're going to be similar, even though they could be different sizes. It's not necessarily congruent though, because your sides here could be 2, 3, and 4. Right? And then they could be 4, 6, and 8. So those obviously would not be congruent. You need some sort of information about sides to do congruence, right? Congruent triangles have the same angles are congruent and sides are congruent. For similar figures, it's just angles congruent. The sides are proportional. So just because you have angles congruent doesn't mean your sides are also going to be congruent. Right? Congruent triangles would be similar though, because your scale factor would just be 1. Right? You'd have 2 over 2, 2 over 4. I'm sorry. Right, 2 over 2, 3 over 3, and 4 over 4. You just have a scale factor of 1. Okay, 12 through 15 here. Explain why the triangles are similar. Then find the value of x. So this one would, again, we have two pair of angles, so you have angle similarity. Then you can set up a ratio. Okay, so 2x is going to relate to 21, right? 2x. 21, and then the hypotenuses here are 40 and 11x plus 4. Okay, we cross multiply, so 21 times 40 on one side and 2x times 11x plus 4 on the other. Okay, you distribute, so 20 times 40 is 840. Over here, you're going to get 22x squared plus 8x. Okay, you subtract 840 from both sides, so you get 0 equals 22x squared plus 8x minus 840. So we need a factor. This is all number 12. So we need something that multiplies to 840. We need a factor of 840. We can also do 22. Let's use the quadratic formula here. So opposite of b plus or minus the square root of b squared, which is 8 times 8 is 64, minus 2, minus 4, I'm sorry, 4ac. 4 times 22 times negative 840. All divided by 2a, so that's going to be 2 times 22 is 44. So negative 4 times 22 times negative 840 plus 64. Let's take the square root of that answer. That's 272. So you have negative 8 plus or minus 272 divided by 44. So that's 280, negative 280 divided by 44, or 264 divided by 44, which is 6. Negative 280 divided by 44 is negative 70 over 11. Okay, you can't have a negative length here. Right, so you do the quadratic formula, this gives us x equals 6 or x equals negative 70 over 11. But you can't use the negative because that's going to give you a negative answer here, so it has to be 6. To check our answer, we could plug it back in. 2 times 6 is 12. So that's 12 over 21. And then 6 times 11 is 66, plus 4 is 70. So 40 over 70, and those are both equal to 4 over 7. So we know we're good. X is going to be 6. Okay, so when you ran into this, I used the quadratic formula because it was going to be too hard to factor. I mean, it would have been hard to figure that out. You would have had 11x plus 70. So one of them would have been 11x plus 70, and the other one would have been 2x minus 12, right? Yeah. These would have been your factors. So I just used the quadratic formula because it was much easier. Okay. All right, 13. Okay, so let's draw the two triangles separate. Let's use a different color. Okay, so I'm going to draw the red triangle here. That's 6 and x minus 1. Okay, and then the blue one will be the large one. Oops. Okay, not blue. Okay, so the blue one is the large one. So this distance here is 6 plus x. Right? And then this distance here is 2x plus 4. So these lines are parallel. So we know that corresponding angles that are created by a transversal cutting through parallel lines are congruent. So we know that these two angles are congruent and these two angles are congruent. So we have angle-angle similarity. It tells us these two triangles, the red and the blue, are similar. Since we have similar angles, the sides are proportional. So we can do 6 over 6 plus x equals x minus 1 over 2x plus 4. And then we can cross multiply here, so we get 6 times 2x plus 4 equals x minus 1 times 6 plus x. So we get 12x plus 24. We got to just FOIL. So we get 6x plus x squared minus 6 minus x. So we have 12x plus 24 equals x squared plus 5x minus 6. If you minus 12x from 24 to the other side, we get 0 equals x squared minus 7x minus 30. And so looks like there are also going to be fractions here. Nope, 10 and 3. So we do our x method, something that multiplies to negative 30 and adds to negative 7 is going to be negative 10 and positive 3. So x minus 10 and then x plus 3. You set each of those equal to 0, so x minus 10 equals 0, x plus 0, so x is going to be 10, or x is going to be negative 3. If you plug in negative 3 here, you're going to get a negative length, so we don't want to use the negative one, so we're going to use the positive one. So let's plug it in and see. Okay, we get 10 minus 1, this would be 9, right? 10 minus 1 gives us 9 here. Okay, 10 plus 6 gives us 16. 2 times 10 plus 4 is 24. So we have 6 over 9, 16 over 24. So our ratios are good. So we know x is going to be 10. Okay, that's a good answer. Okay, 14 here. You have vertical angles. So we know that we have one pair of angles. We also know 9 over 12 equals 21 over 28. So that's 3 over 4 equals 3 over 4. So we have one pair of angle, 2 ratios equal. So that means we have 2 sides proportional and one pair of angles congruent. So we can use side angle side to show that those 2 triangles are similar. Okay, from there we can set up our ratios. So we know that 9 over 12 and 21 over 28. We also then know that 18 corresponds to 4x minus 4. Right, so we can pick 2 of our ratios. I'm going to pick 9 over 12 and 18 over 4x minus 4. We cross multiply, so 9 times 4x minus 4 equals 12 times 18. So we get 36x minus 36. 12 times 18 is 256, right? $216. Okay, add 36. It's 252, so 36 equal x equals 252. Divide by 36, and we get x equals 7. If we plug that back in, this is going to be 18 over 4 times 7 is 28, 24. So 18 divided by 24 is going to be 3/4, the same as the other ones. So x is your answer here. Right, that's 14. Okay. 15. It's telling us this side is 10. So that means these sides are also 10, and then these are 2x are also going to be 4. So we really can ignore the x here, right? All the sides are 4 there, all are 10 there, so we have 10 over 4, 10 over 4, and 10 over 4. So we have 3 pairs of corresponding sides the ratios are equal with. So we have 3 proportional sides, so we have side, side, side. Okay, then we guys got to find x. So 2x is going to equal 4. So x has to be 2. Right? 10 times 2 is 20 minus 10 is 10. Okay. And then the last one is 16. Think about a plan. A right triangle has legs, 3 legs, has legs 3 centimeters and 4 centimeters. And a hypotenuse of 5 centimeters. Another triangle has a right triangle, has a leg of 12 centimeters. Find all the possible lengths of the second leg that would make the triangle similar. For each possible length, find the corresponding hypotenuse. Okay, so we could have 2 scenarios here. 12 could be the long side, or 12 could be the short side. So this is just like the one from the last one with the rug, the largest rug and the shortest rug. We just have to check both scenarios. So for the first one here, our ratio would be 4 over 12 equals 3 over x. We cross multiply, we're going to get 4x equals 36. Divide by 4, x would be 9. Okay, if we try the other one, okay, 4 is going to correspond with x, so it's going to be 4 over x. Okay, and then 3 would correspond with 12. You cross multiply, you're going to get 3x equals 48. So x is going to be equal to 16. Okay. Right, your right triangle 3, 4. Yeah, so this could be it could be 9 or it could be 16. Okay, to which measure must you compare the 12? You could, so the 12 could be compared to 4 or it could be compared to 3. Right? Then how can you find the measure of the hypotenuse? So you can use the Pythagorean Theorem, a squared plus b squared equals c squared, or we can use our ratio of our sides. So for this one, if this was a 9, right, we could do, you just pick a ratio. So again, you'd have 4 over 12, 3 over 9, and then you'd have 5 over, you could call it z. Right? So if you cross multiply, you'd have 3z equals 45. So z would be 15. Okay, if you did it with the other one, right, you would have 4 over 16 equals 3 over 12, and then 5 over, we could call it w. Right, this would have been 16. Okay, and then you cross multiply. 3w equals 60, so w equals 20. So your hypotenuses could be 20 or 15. Okay, so we're good on that.